Alright, welcome to the 5th episode of the Type Maps in LibGDX series. And yeah, like we can see here, today we are taking care of moving the player around, because we got collision detection, we got gravity, but that's all pretty boring as long as we cannot move around in the first place. So yeah, obviously to move around we need to change something in the player class, and the first thing we want to do is to implement the input processor interface. So import that and add the implemented methods. Well, the reason for this is if we implement the input processor interface, this is able to process some input like the name says, and that's actually what we don't do. So let's return true in these methods here because the input is handled. And let's have a look at the top again. We have this velocity vector 2 here, which is pretty much just modifying the position with these ZX. You see, here's the velocity again, and we already have the gravity modifying the velocity. So if the gravity can move the player around through the velocity, we can do that as well. Let's set up a switch statement, key code, and just some basic things like keys.w, break, keys.a, break, and keys.d. Also for key up, but we'll let that empty for now. So in case the A button is pressed, we want the player to go left. So we can just take the velocity, and take the x-axis and just equal minus speed, because, well, speed makes sense, that's the speed that we want to move around with, and minus because we want to move to the left on the x-axis. So for D we want to move to the right, and that's pretty much the same, just that we have to equal this, yeah, to speed. That's it. We can already move left and right now, but we cannot stop, because this just takes care about key down, but if we want to release the key, the player should stop moving. So we can go in here and say, in case we released keys.a, or in case we released keys.d, the velocity on the x-axis should be set to 0, so we don't move on the x-axis at all anymore. Now we just have to do one more thing. The player now implements the input processor interface, but nobody knows that, so nothing's gonna happen. We just have to set the input processor to the player. That's it. Like with stages and everything, like what I was talking about in the previous episodes on my other series that you probably watched. Yeah, we set the input processor, so that is where the input events are going to go. Let's try it out. And there we go. We can move left and right. Better than nothing. But still, a platformer without jumping is kind of boring. So let's add jumping to this guy. And yeah. So let's think about this theoretically. If we press W, let's actually go down for this. Here. If we press W, we don't just want to set the velocity on the y-axis to speed. Well, this pushes the player up, but we could just press W all the time and we would have the ability to fly. So this is kind of boring. We want to set something like, if we can currently jump, then we want to set the velocity to speed. And because we just jumped, we cannot jump anymore. We just have to set up this can jump boolean up here. And that's it. well, not entirely, but this enables us to do this. So if we can currently jump, we want to jump, and then we're in the air, and in the air obviously nobody can jump, so we set can jump to false. Now we set can jump to false, and that's it. We never set it to true anymore, so that has to change. When should the player be able to jump again? Right, when he got on the ground. So when does the player actually get on the ground? Well, in the collision system we have some place where he gets on the ground, and that is if the if he collides on the y-axis. So if he collides on the y-axis, there's actually two cases where he can collide, and that is one time the case that he is going down, or the case that he is going up. So let's actually put this in the case he's going down, because if he was going up and we just put this in here like this, can jump equals true, this would already work, but he could get up, you know, he going up, and he could, like, for example, jump against the ceiling and then just jump all the time again, and like, yeah, hang, or you know, move on the ceiling, because there is a collision on Y, so we said can jump to true. But we actually don't want to do this. Just want to go into this one here, because this is if the player was going down, and if then a collision on Y appears, occurs, or however that word is, then we want to set can jump to true. So let's actually not just say can set jump to true, but just can jump to collision Y. So if this is true, can jump is also true, but just if we have been moving down. That was a kind of weird explanation, but I guess it's working. So let's try it out. And yeah, I can jump. I can jump, and I can jump. Great. Let's try out if that is fixed. I cannot jump if I just got against this. Let's try what happens if we move this into general collision on the y-axis and just set it to true. You see, I can just stay up there because there's a collision on the y-axis, and I can just say, okay, it collided, so I can jump again. But that makes no sense. Stuff like that is possible. And what the hell is this? That's no physics. So we move can jump to the case we moved down, and yeah, but if we collided on the y-axis. So great. Now this is fixed, and we have one nice moving around player. Yeah. If you make this map again, don't forget to set the blocked property on this grass and on these kinda bricks here. But I didn't set them on the trees, so I can pass through them. And yeah, let's actually get one more thing, and that is to let the camera follow the player. Really not this complicated. Just in here, camera dot position dot set, and then we give it 3 values. The x is player dot get x, and we want to do it exactly plus player dot get width divided by 2. So this is going to be exactly in the middle of him. Player dot get y plus player dot get height divided by 2, and 0 on the z-axis because it's 2-dimensional camera. And then we want to update the camera. And just one more thing, if we update the camera here, we don't have to do it here anyway, so we can just remove this. Also, we want to zoom in a little bit more, because this was really far too wide out in my opinion. So let's actually divide this by 10 and divide this by 10, which will give us a yeah, 10 times smaller viewport width and viewport height, so it will all appear bigger. Okay, 10 was maybe a little bit too much. This looks like crap. 2.5? I don't know. Yeah, this is okay. And somehow this is not moving smoothly. Do you see that? Well, whatever. Okay. So is there anything left that we can do? Well, there's something we can do. For example, if we wanted the tree to be in front of the player, we can go into the map editor and at first remove these trees like this. Hello? Okay, it's a little bit slow at the moment. Remove the trees. Remove the trees. Okay, let's actually open this up again with the system editor. And now I can say we remove the trees here. And we add another layer. Add on that layer, which is on top. Like now it would, yeah, anyway, it's on top. Now it would be below, and now it is on top again. So on this layer on top, we want to render the trees. And let's save this. Let's actually give them some name, like background and foreground. Then save this. Then we have to refresh the assets folder. And then it would still be the same if we just continued. We could still go over the tree. So we have to render the background first, then render the player, and then render the foreground. So to do this, we go into here and we say renderer.render, and we give it an int array of layers. So there is this map. Where do we have the map? Yeah, we have the map, which is called map.getLayers.get, and we can give it the string how we named them. So let's say background, and then get what? Get shit. Well, we could give it an int array, but we could also just do it like this. Map renderer.render tile layer, and then we get this tile layer from here. What's this problem? Oh yeah, we have to cast this. Fine. And then we just rendered the background, but we also want to render the foreground after we rendered the player. So renderer.render tile layer map.getLayers.get foreground, and we have to cast again. So I think this is going to work. Okay, it's not really. What is his problem? Sprite batch begin must be called before draw. Okay, so if we render the tiled layers, he doesn't automatically begin, and end with a sprite batch, so we have to do that ourselves. We begin with the sprite batch, we render the background, we render the player, and we render the foreground, and we end with a sprite batch. Fine. The background is behind the player, and the trees are in front of the player. I can hide behind a tree. Nice. This is all working, and I think this episode is also long enough now. Oh yes, it is. So alright, see you in the next episode. Thanks for watching, and all that stuff that people say after their videos are over. Okay. Yeah, actually, thanks for watching.